era of attack jets and precision-guided munitions, the unprotected infantryman stands little chance of survival. Since World War II, the infantry has gradually become more and more mechanized. This video ordnance program examines today's infantry combat vehicles. Land warfare in World War II was dominated by the tank. Tanks defined the speed and momentum of land combat. When tanks had first appeared on the battlefield in World War I, they posed no difficulties for the foot soldiers. The early tanks were slow, hardly faster than the walking speed of the infantry. But by World War II, tanks traveled at speeds up to 30 miles per hour, nearly 10 times faster than the infantrymen. The early failures of tanks in the First World War were largely attributable to the separation of the tanks and infantry. Working in conjunction, they were a powerful combination. Fighting alone, they were isolated and weakened.
Most of the early tanks that we saw in World War I were very primitive in their automotive capability and could do little more than keep up with a walking man. However, as the war drew to a close, the British themselves especially were looking towards developing medium tanks with much higher speed capabilities, say in the 20 to 25 mile per hour range, which John F.C. Fuller, who was the Chief of Staff of the British Tank Corps, was envisioning for breakthrough purposes and to exploit and to mess with the enemy's command and control and line of communications or supply in his rear areas. And once you start doing that, once you start sending tanks deep into the enemy's rear, you must have infantry that's capable of keeping up. Although that didn't develop functionally in World War I, the vision was there, the capabilities of faster tanks became more and more preponderant during the 1920s and 1930s, and then we see the development of vehicles that can keep infantry under armor and up with those tanks as they go deep into the enemy's rear.
Trucks were an obvious method to transport infantry, but trucks had two disadvantages. They could not keep up with tanks in rough terrain, and they had no armor protection. For infantry combat, more capable vehicles were needed to carry out blitzkrieg tactics.
Armored infantry vehicles were an essential element in early blitzkrieg warfare. The reason is that blitzkrieg isn't only tanks, as many people think. It's really what we would call today combined arms. That is to say, it's the integration of tanks, infantry, and artillery, the three traditional combat arms. Now, why the infantry vehicle was important to this is that without an infantry vehicle, the infantry simply couldn't move with the tanks. The infantry wasn't fast enough to keep up with the tanks. The Germans were the first to really put this type of doctrine to the test. They started to use mechanized infantry first on a small scale in 1939 in Poland, then later in France in 1940, and then finally on a larger scale in Russia in 1941. And the other armies quickly followed suit, the British Army, the American Army. Some armies, for example, like the Russians, never did mechanize their infantry during the Second World War, or simply motorized it, put it on trucks, which wasn't as effective. And for that reason, their infantry was never quite as successful as those armies which did mechanize by putting the infantry onto infantry transporters.
The Second World War saw the first use of infantry combat vehicles. The U.S. Army's M3 half-track was a typical example of a World War II infantry vehicle. It used a track assembly on the rear section to give it better mobility than a truck using wheels alone. And it was lightly armored to protect the infantry squad inside from enemy rifle and machine gun fire. It gave added firepower to the infantry squad by adding a .50 caliber machine gun. But it gave the infantry squad no overhead armor protection, since the added weight would have been too great a burden to the vehicle. The infantry fighting vehicle evolved slowly after the war. The Soviet BTR-152 of the early 1950s was little better than the wartime half-tracks. It was basically a truck with armor plate. But tank technology was moving ahead faster than vehicles like these. Clearly, additional armor and mobility was needed. In the 1950s, a new generation of infantry vehicles emerged called APCs. APC means Armored Personnel Carrier. The United States Army's M113 was typical of this type of vehicle. They were fully tracked with more mobility than half-track vehicles and were fully armored, giving the troops more complete protection.
I think more than anything it was lessons of the war, as well as the fact that you are looking at trying to come up with an armor envelope that's going to protect your crewmen and your infantry from shrapnel, from air bursts, that sort of thing. That gives you a complete armored envelope. Going to the full track gave them a much better off-road capability than the half-track design did. And let's face it, with full track versus half-track, on road you really don't have that much difference in capability. But with the wheel, you're subject to tires getting punctured and to the fact that you're going to have less off-road capability without the full track. So the decision was made to go to the full track design.
The basic role of APCs such as the M113 is to bring the infantry squad forward with the tanks and then dismount the squad and let them fight on foot in the traditional infantry fashion. The M113 was the most widely produced American armored vehicle of all times, with over 70,000 manufactured. It is used not only for transporting infantry, but in many combat support roles as well, such as its use as an ambulance to carry wounded troops. The M113 is also used as the basis for tank hunting missile vehicles, armed with the TOW missile. The original version, like these Saudi TOW vehicles, have the missile launcher completely exposed. The more recent version, the M901 ITV improved TOW vehicle that we see here, has the TOW missiles mounted in a special armored hammerhead launcher, so that the crew stays protected within the armored hull of the vehicle. When ready to fire, the missile launcher can be elevated above the roof, allowing the crew to position the vehicle behind a hill for further protection. This version of the M113 is likely to serve on in the U.S. Army long after the basic infantry carrier has been replaced by more modern vehicles. The M113 has been widely exported around the world. In the recent Gulf War, it not only served with the United States Army, but with the armies of other coalition forces, including the Egyptian and Saudi armies. The M113 has its counterparts in other armies, such as the FV-432 in the British Army. The Chinese equivalent of the M113 is the Type 534 infantry transporter. It is roughly the same size as the M113 and very similar in shape. During the Gulf War in 1991, Chinese Type 534s were the most common infantry vehicle in the Iraqi service, such as these vehicles knocked out in the Battle of Khafji. The most challenging requirement for infantry vehicles comes from Marine units. Marines not only need transport across terrain, but also need transport across water as well. The U.S. Marine Corps pioneered amphibious infantry vehicles, which they call Amtraks. The current design, the Amphibious Armored Assault Vehicle 7, was first used in the early 1970s and has been modernized since then. It is larger than the Army counterpart, the M113. Size is necessary, since large size means greater buoyancy in the water. The AAV-7, although it's made of aluminum armor, easily floats even in heavy surf conditions. Its propulsion in the water comes from water jets located in the rear of the vehicle. It can be steered in the water by altering the flow of the water jets using special baffles at the rear. On land, its propulsion is conventional tracks. The AAV-7 can be launched from amphibious warfare ships lying offshore. The vehicle is closed up to prevent the waves from entering the fighting compartment. During the Gulf War, the AAV-7 was the primary infantry vehicle of the Marine Corps. Improvements have been added to the AAV-7 in recent years, including additional armor and a new turreted weapon system to give the vehicle greater firepower. The AAV-7 may seem a stranger in dry deserts like those of Saudi Arabia and Kuwait, but in fact the Marine Corps has practiced extensively in desert warfare. Although tracked vehicles offer better mobility than wheeled vehicles, it is not the only approach to transporting infantry. Tracked vehicles are more complex and expensive to operate than wheeled vehicles. In some areas, such as in deserts, urban areas, or dry plains, the terrain is equally suitable for wheeled or tracked vehicles. So, for the sake of economy, many armies adopted wheeled infantry vehicles. These vehicles have little in common with the wheeled armored vehicles of the Second World War, having much more sophisticated all-terrain features. A good example of this type of infantry vehicle is the South African Rottle infantry carrier. The Rottle operates in a dry terrain where mud and snow are not a problem. As a result, a wheeled layout is more economical than a more complex and expensive tracked layout. The Rottle has several other unique features. In the fighting between the South African forces with the armies of Angola and Cuba, mines have been one of the most common threats to armored vehicles. The hull of the vehicle has been designed to better withstand mine damage than conventional armored vehicles. While the vehicle may be damaged beyond repair, these features can reduce casualties among the crew. There are several variants of the Rottle which provide additional firepower to the infantry, including a 60mm mortar and a heavily armed 90mm gun version. Many European armies also find wheeled infantry vehicles to be a practical solution for some missions.
Basically, wheeled vehicles tend to be cheaper on life cycle costs. They also have much greater strategic mobility. They're easy to repair. Driver training is much reduced. Where tracked vehicles, you need dedicated maintenance crews, you need special track licenses, and so on. So many armies of the world now are leaning towards a fleet of wheeled vehicles, very often based on common components from the civil industry, like engines and transmissions. There's a very large trend towards wheeled vehicles, particularly in the French army, of course.
The French army uses both wheeled and tracked infantry to provide a reasonable economic mix. The French Army's tracked infantry vehicle is the AMX-10, while its wheeled infantry vehicle is the VAB. The Renault VAB wheeled infantry vehicle uses a sophisticated independent suspension system which provides better cross-country mobility than simpler suspensions borrowed from civilian trucks. The VAB carries an infantry squad usually numbering 8 troops with their equipment. In the French Army, the heavy AMX-10P is used by mechanized forces committed to European defense, while the VAB is allotted to units of the Rapid Deployment Force used overseas. Like many wheeled armored vehicles, the VAB can swim across small water obstacles such as rivers. The VAB's light weight makes it very easy to carry and transport aircraft, thereby giving it additional strategic mobility. The VAB has also been extensively exported and saw combat duty during the Gulf War in French and Qatari service. In the British Army, the GKN Sankey Saxon was adopted in the 1980s as an economical supplement to the much more sophisticated and expensive Warrior tracked infantry vehicle. The Saxon is a very elementary infantry carrier, offering its troops basic armored protection and mobility. Sophisticated wheel suspensions can rival tracked suspensions in cost. The relative simplicity of wheeled armored infantry vehicles compared to their tracked relatives has made them a good starting point for new industrial states to learn how to manufacture armored vehicles. Some of the vehicles are locally designed, while others, like the Simba, are designed in Europe and manufactured by the new industries. In the mid-1960s, a new approach to infantry vehicles began to emerge. The Soviet Army, convinced that modern land warfare might involve nuclear weapons, began designing an infantry vehicle which would allow the troops to fight from inside.
The reason for the development of the BMP had a lot to do with changes in Soviet doctrine that were taking place in the late 1950s and early 1960s. The Soviets began to believe that the battlefield in Central Europe would probably go nuclear very quickly. It would not be a conventional battlefield. That means that the infantry couldn't survive on the battlefield unprotected due to the radiation hazard due to the blast effects. And so what was needed was some method to allow the infantry to fight on the battlefield and yet be protected against this nuclear threat. And the means was the infantry vehicle. The advantage of the armored infantry vehicle is that the armor essentially protects the infantrymen from the hazards of radiation and the hazards of blast. Now the problem is if they had simply used the earlier generation of infantry vehicles, which had no firing ports and had no weapons, they would essentially just be moving around in tin cans. They have no ability to fight. So the second important innovation that the BMP, that the early infantry fighting vehicles added, was the ability of the infantry to fight from the vehicle, to give the infantrymen inside the vehicle firing ports so that they could fire their rifles outside the vehicle. And at the second time, there was an acceleration in the firepower of the infantry squad by mounting a heavier weapon on the vehicle. In the case of the BMP, it was a 73mm low-pressure gun and an anti-tank guided missile.
The BMP-1 was the first of the new infantry fighting vehicles, or IFVs. Each infantryman had a small firing port through which he could fire his rifle, and the vehicle had a small gun and an anti-tank missile to defend itself against enemy tanks. The German army had always been a proponent of heavily armed infantry vehicles, even its first post-war vehicle, the HS-30. In the mid-1960s, the German army began development of a new infantry vehicle, the Marder. Like the BMP, the Marder also allowed the crew to fight from inside. The main vehicle weapon, though, was not designed to fight enemy tanks. The Marder is armed with a 20mm automatic cannon. The Germans felt that the tank fighting should be left to the tanks. The gun on the Marder was intended to fight enemy infantry in buildings, entrenchments, or light armored vehicles. The Marder was the first infantry fighting vehicle adopted by NATO. It symbolized the continuing pioneering German role in infantry mechanization. It took nearly a decade for other major NATO armies to follow the German lead. The Marder is a heavier vehicle than the Soviet BMP, so it cannot swim. Instead, the designers fitted it with a retractable snorkel, which allows it to wade across most European rivers. Like most infantry fighting vehicles, the Marder is cramped and noisy inside. Many infantrymen appreciate the armor protection such vehicles offer, but they exit the vehicle with some relief. U.S. Army's search for an infantry fighting vehicle was more protracted than in the German or Soviet case due to the disruption of the Vietnam War. In the early 1970s, it began searching for such a vehicle. FMC Corporation, which designed the successful M113, developed further evolutions like the one we see here. These had a turret as well as firing ports for the troops. Although such a vehicle had distinct advantages over the older M113, it was still not enough for the U.S. Army.
Well, I think the big catalyst here is the development of the M1 main battle tank. Here we've got a vehicle that has a tremendous off-road capability, cross-country, shoot on the move, at speeds in excess of 30 miles per hour. And the M113, our standard vehicle up to that point, just wasn't capable of keeping up with the M1 tank. And so consequently, we looked for another design that automotively would be able to keep up with the M1 series of vehicles, and also to give them the same capabilities that we've been seeing in the infantry fighting vehicles developed in the Soviet Union, in Germany, and England. And so we come to an agreement to produce the M3 and M2 series, Bradley series of fighting vehicles.
The Bradley offered 3 critical improvements over the earlier M113. It was fast enough to keep up with the new M1 Abrams tank in combat conditions. It represented a fundamental leap forward in firepower, and it was more heavily armored than any previous infantry transporter. The Bradley is the most sophisticated of the infantry combat vehicles in service today. Compared to the first generation of infantry combat vehicles like the BMP-1 and the Marder, it has superior firepower. The 25mm Bushmaster cannon is not significantly more powerful than the cannon on the Marder, but its fire control system makes it much more effective. The gun is stabilized, allowing the Bushmaster to be fired while the vehicle is moving. In addition, the Bradley is fitted with a thermal imaging night sight, which allows it to fight day or night. Such weapons represent a general trend in the evolution of infantry firepower. Since World War I, the infantry squad has grown smaller, but its firepower has grown immensely. In the First World War, a typical infantry squad was 20 men or more, armed only with rifles. An infantry squad in a Bradley has 7 men, 2 of them armed with squad machine guns, and the rest with assault rifles. In addition, the squad can carry a Dragon anti-tank missile, as well as other weapons such as anti-tank rocket launchers. The heaviest firepower is on the vehicle itself. Besides the 25mm Bushmaster cannon, the Bradley also fires a tow missile, which is capable of defeating nearly any tank on the modern battlefield. There is some controversy among infantry forces whether such missiles are essential to armored infantry vehicles. In the British case, the answer has been no. The British Army developed its own infantry fighting vehicle, the Warrior, after the Marder and Bradley. The Warrior differs from current infantry fighting vehicles in 2 respects. It does not have firing ports for the infantrymen, nor is the basic version armed with an anti-tank missile. Its primary weapon is limited to the 30mm Raden cannon in its turret. Some infantrymen argue that heavy anti-tank firepower distracts the infantry squad from their primary missions. They believe that tank fighting is best left to the tanks. The Germans have reconsidered their views on infantry anti-tank missiles and now fit the Milan anti-tank missile to their Marder infantry vehicles. Even the Soviet Union has followed the American and German approaches on vehicle armament with their BMP-2 infantry fighting vehicle. The BMP-2 differs from the older BMP-1 by substituting a 30mm automatic cannon for the old 73mm low-pressure gun. This weapon is very similar in performance to the Bradleys or the Warriors guns. The Soviet Union has gone one step further in the infantry firepower debate with its new BMP-3 infantry vehicle. First deployed in 1990, the BMP-3 not only has a 30mm gun like other infantry vehicles, but a 100mm gun, giving it firepower almost equivalent to that of a tank. In Europe and the United States, the interest has turned from firepower to protection. Infantry vehicles, even the thickly armored Bradley, are still vulnerable to infantry anti-tank weapons such as rocket-propelled grenades and anti-tank missiles. The real barrier to more heavily armored infantry vehicles is cost, not technology. Current infantry vehicles cost half as much as main battle tanks. Future infantry vehicles, should they be armored as heavily as tanks, would cost as much as tanks. No army has been able to afford this. Yet improvements are being made. The M2A2 version of the Bradley adds additional armor to prevent its penetration by the automatic cannon of other infantry fighting vehicles. British Warriors, deployed during the Gulf War, had special applique armor added to give extra protection against enemy anti-armor weapons. Even if the technology of infantry warfare has changed remarkably over the past 2 decades, the basic job of the infantryman has not. The infantryman may now ride into battle, but he is expected to retain all of the traditional fighting skills of earlier foot soldiers. The ride into the battle zone is only a prelude to the infantryman's real tasks. Technological changes have allowed the infantryman to survive on the modern battlefield. But no doubt many new challenges lie in store for the infantry's combat vehicles.